Hey, Plumber-Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hey, welcome back. We have yet another presentation from Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we'll be looking at Unit 23, which is Wye and Tee-Wye Assemblies. Whoa. We gotta stop right here. From the very title of this, I think we have things wrong. We will look at some of these, Y's, Tee-Wye's, etc., but let me just point out, at least in my geography, nobody calls it a Tee-Wye. I have never heard anyone call it a Tee-Wye. Let's look at the manufacturer. Let's see what the manufacturers have to say and what they call it, because when I buy a fitting and I'm using it, let's see what they have to call it. Okay. To prove my point, here we have Charlotte Pipe. Charlotte Pipe is one of the big manufacturers in drainage, waste and vent piping. And this catalog shows us PVC and ABS drainage pipe fittings. Let's have a look. What do they call these fittings, shall we? Observe with me here on page 38 from Charlotte's dimensional catalog. This shows you all of the fittings they have and the exact dimensions and measurements of them all. This is like our data tables in the back of this book, only there's a catalog produced by the manufacturer to provide those measurements, and so we can do takeoffs. But let me just make the point. It says right here, sanitary T. That is what it is called by the manufacturers, and therefore it is called the same by our suppliers, and in consequence it is called a sanitary T or a san-T by those of us who are in the trade. Let's have a look at another fitting on page 50 of the same catalog. It's a similar fitting to what you see in Unit 23, but Unit 23 is calling it a long Tee-Wye. We don't call it a long Tee-Wye, we call it a combination fitting. Combination Y and eighth bend. You can see Y on the bottom half of this page. There's a diagram that shows a Y and an eighth bend, and you put those two together and you get a long sweep that creates a 90-degree inlet, and we call it a combination fitting. Some people will call it a combi. Sometimes they'll call it a combo. You know, like you go to the restaurant and you order a combo meal. Well, these are the terms that are commonly used in reference to this fitting. On page 53 of this dimensional catalog, we find the Y, and this is correctly named in the Mathematics for Plumbers and Pipefitters book, and is what we call it out in the field as well, the Y. Now, any of these could have a reducing connection, an inlet, so, you know, if that was the case, we would call it a reducing san-T or a reducing Y or whatever, but sanitary T or san-T, Y, and combination fitting, these are the names we ought to be using. Why am I making such a big deal out of all the names? Well, I want you to be able to call them by the correct name so that you sound competent when you're out ordering parts or working on the project in the field. So, we are going to be using the names in here because that's what it says all over the pages in the book, but I just want to make it very clear that the names of the manufacturers is what we should call them, and please don't embarrass yourself by calling it by these names. Yeah, people might figure out what you're talking about, but let's just stick with what they're actually called in the field. Alright, there's one other thing that I have to make very clear as we look at this illustration. The sanitary T, which they're calling a Tee-Wye, is in an orientation which it should never be installed in any drainage system ever, according to the International Plumbing Code. So let me zoom in here. This image right here should be turned like this. This is the only way that you would install it in a drainage situation, because it has a short sweep. Now you can install it in a variety of ways, whatever. When it's venting and you're connecting vents together, it's just airflow. But when it's a drain, never put it on its back, never put it on its side. It can only stand upright with the inlet coming in. That's how you install a sanitary T. Okay, just wanted to make sure that's totally clear as we begin this unit. And to start this unit, let's go right to sample problem 1. This does look somewhat familiar to some of the other diagrams we have dealt with in the last unit. However, you will notice that in place of certain fittings that we had in the past, now we have a combination fitting at the bottom of this diagram. We have a Y coming up. We've dealt with that last time. At the top, rather than 90s, we have 2 sanitary tees. So this is going to be the difference. We're going to be dealing with a different fitting. Therefore, we're dealing with different fitting allowances as we deal with these. And therefore, we're going to need some additional information. You will find all of this as described in Unit 23 on Data Table 8 for regular Ys, Data Table 9 for reduced branch Ys, Data Table 10 for regular Tee-Wys or sanitary tees, and Data Table 11 for reduced branch sanitary tees. Sample problem 1 asks us to solve for center to center and end to end lengths of threaded pipes J, K, L, and M. And we're looking at the diagram there. So let's get into that. Let's figure out our center to centers first, as we've done in the past. Starting at the bottom with J, it's given to us as 16 inches from the center of that combination fitting up to the center point of the Y as those pipes branches come together. Next, let's find K. We know from the left side that the overall is 60 inches. We know that J is 16 inches. So if we take 60 minus 16, we can get our K center to center measurement, which is 44 inches. How about L? For L, we're going to look up to the top. We have an offset here. It comes off from that Y. As it branches out, it comes to a 45 and then turns up straight and goes parallel. The offset between those is 24 inches. So we can use our plumber math that we're used to. We take 24 times 1.414. We know that we can use that because these are 45-degree angles. We're using 45-degree fittings. 24 times 1.414 is 33.936, or 33 15/16. Finally, let's look at M. To solve for M, we're going to take our overall, which is 60 inches. We'll subtract off what we know at the bottom for J was 16. That gave us 44. Then we also know from this triangle that if it's 24 inches for the offset, then from the center of the Y coming up to the center of where that 45-degree fitting is also 24 inches. That means we can take our 44 and subtract 24. It leaves us with 20. Or in other words, we had 60 minus 16, also minus 24. That's going to leave us with 20. There we have our center to center measurements. Let's look at how we get our end to end as we use our data table in the back to be able to subtract for the fitting allowances for our different fittings on this sample problem. To find our fitting allowance for J, we're going to need to subtract for that combination fitting at the bottom of our system. And so we're going to jump back here to data table 10. At the bottom it has the drainage Tee-Wyes, or we've got our sanitary T and combination fitting. On the right are the combination fittings. Remember, we are dealing with 1.5-inch threaded pipe on this sample problem. So we come down here and we look up 1.5-inch and come across. Now there's different dimensions. Look at the diagram. The overall length as we go straight through is A. There's another center that's D. That's from the face of the branch to the center line of the fitting, going straight through. And then we have C, which is from the face of the bottom of the fitting to the center line of the branch. Keeping that in mind, what we're looking for here is a piece that we can deduct from the center line of the pipe up to the face. That would be D. We want D. So we look up D here on 1.5 inches, and D is 4 3/16 inch. And then as we look up our typical thread ends, they have that over here on the right side. The thread end for 1.5 inches is 1/2 inch. That means, again, the pipe goes into the fitting 1/2 inch. And so we'll need to subtract that half for our fitting allowance. All right, I gotta pause here. This video's all over the place today, but let me just say, on behalf of all of those who produced Mathematics for Plumbers and Pipe Fitters, I am sure they're very sorry for all of the mistakes that they left in here when they were editing this book. They've overlooked yet another mistake. I wish that I could have a lot more confidence in this book, But as we go through this, we find another issue here on the sample problem. I'll point it out, but apologies up front. I'm not like a math wizard myself. If you had me in class, you'd be correcting me on the board all the time because I'm not perfect, you know. But with videos, I can cut all that out and try to get it right. That's what I'm going to do here because they kind of messed up, and let me show you why. On the other side of our center to center length from J, we have to subtract the Y, a portion of the Y to the center. And in the sample problem, it has us taking off D. Now, if you look at the diagram, that is the section from the center line out to the face of the branch. That's not what we're subtracting on J, not at all. We're subtracting that short piece off the bottom. To get that, we would have to take A, subtract C, and it's going to give us a shorter length that we would then subtract. And we'd also have to subtract for the amount of pipe. So let's do that while we're here. On data table 8, and mind you, we're on the bottom half of the page because these are the drainage Ys. So that's the reason we're using these measurements as opposed to the Ys that are up above. But in reality, like when we're doing drainage, that's about the only time we use Ys. If you're doing pressurized pipe, you don't use Ys. So there's that whole thing. But okay, let's just do that math real quick. Here we go, 1.5 inch pipe. A is a 5 1/4. Then we can see that's the center of the Y where that branch and the center line come together to the face. We're going to subtract that off, which is 3 7/16, and that's going to give us a total of, I'll tell you what, let's jump over to my pad and we'll finish this whole J thing so you can see. I'll write it out on the screen.
All right, let's crunch these fraction measurements as we're trying to figure out the missing piece here in our sample problem. If we have 5 1/4 and we're going to subtract 3 7/16. Well, to subtract fractions, first of all, you need to get them with the same common denominator. That's the part on the bottom of the fraction. So if I take this quarter and kind of convert that, I can say 1/4 times what equals 16. I need 16ths, right? Well, if I times it by 1, then it won't change the number itself, but it will give me what I need, and I'm going to times it by 1 in the form of 4/4. So 4/16. Hopefully that was obvious to you. Okay, then we take 5 4/16 minus 3 7/16, and I still got a problem here because 4/16 cannot subtract 7/16. If you remember, we need to borrow. So I'm going to borrow from this 5 here, and in 16ths, that's going to be 16/16 if I take 1. So that's going to be 4 since I borrowed 1, and 16/16 plus 4/16 minus 3 7/16. Okay, now we're getting somewhere. Oops, check that out. I put a times. Don't times that. That's a plus. Plus. Okay, corrected. So that leaves me with 4 20/16 minus 3 7/16. So finally, both my whole numbers and my fractions are in a position where I can subtract. And that's going to leave me with 1, and 20 minus 7 is 13/16. That's going to be my fitting allowance for that Y.
Moving on to the end-to-end measurement for K, we figured that for center to center, we took 60 and subtracted 16. What we knew was that section for J, and we got 44. So K equals 44 center to center. We're going to go back to our data table number 8 in the back of the book. Let's look up what portion of this Y we need this time. As we look that up, we get C equals 3 7/16, and then we're going to subtract off the half for the thread in. And then we go over to data table 10, and as we look up what do we need to subtract for the sanitary T at the top, we're going to subtract off that bottom section, which is C, and that's going to be 2 7/16, and then taking into account the thread in, 1/2 inch. Let's run the math. End to end equals 44 minus, in brackets, 3 7/16 plus 2 7/16 minus 2 times 1/2 in brackets. crunch that all out. They're just speeding this up for us, and we're going to get 39 1/8. Follow me through here as we solve for the end-to-end measurement for pipe L. First of all, our offset was 24. We times that by 1.414, and we got 33.936, or 33 15/16. That's our center-to-center measurement. Going back to data table 8, we find that we're going to subtract off D this time. This is time that we really want to subtract off D because it's the branch coming off of the Y. And that's 3 7/16. And then we're going to take into account the thread in. The pipe comes into that 1/2 inch. If we go back over to data table 5, where we have our elbows, we're coming into a 45-degree elbow. And our face to center measurement on A is 1 7/8. We're going to subtract off from that our 1/2 inch. Let's line this all up. End to end equals 33 15/16 minus 3 7/16 plus 1 7/8 minus that 2 times 1/2. All that's our takeoff in the brackets. When we get all that punched together, then we end up with 31 3/8 is our end-to-end measurement for pipe L. Finally, let's solve for our end-to-end measurements on pipe M. As we found our center to centers, we took 60 inches and subtracted off the 16 and the 24. That left us with 20 inches up there at the top. Using what we know about our 45 from data table 5, we're going to subtract off 1 7/8, and we have to take into account a 1/2 inch thread in. From data table 10, on the sanitary T at the top, we're going to take off 2 7/16 and taking into account the 1/2 inch thread in. So we get end-to-end equals 20 inches minus, in brackets, 1 7/8 plus 2 7/16 minus 2 times 1/2. And once we've sorted all that out, we're going to get 16 5/16. Let's move on to sample problem 2. It says solve for center to center and end to end measurements for N, O, and P. We have a very different diagram than the last one we looked at, right? But you'll notice that in place of certain fittings, we do have sanitary T's and Y that we're dealing with, and then normal 45. If we follow this pipe from the top down, the drainage is going to come into the santee and drop down vertical into the 45-degree fitting. It's going to angle over into the Y. It's going to level out, run horizontal, and then come into another sanitary T. That's what we've got for this one. It's 1.5-inch threaded pipe. Let's have a look at our center to centers. How do we get N? Well, if we have the overall of 44 at the top, we know we can subtract off that section of the triangle. We see that triangle happening over on the right side. They're not giving it to us all at once, right? On the right side, we see 30 inches and then 12 inches. Well, the simple on that is P, right? P is 12, we got it. But we can subtract 12 from 30, and that's going to give us the remaining section of that triangle. That side of the triangle is going to be 18 inches. If that is 18 inches, then we know coming across horizontally, the other leg or side of that triangle is going to be 18 inches. So we can take 44 and subtract 18. We're going to get 26 inches. Perfect. Well, then we're halfway there to O already. Because on O, we're going to figure out our diagonal in that triangle. And to do that, we're going to multiply 18 times 1.414. That's going to give us 25.452, or 25 7/16. So we then have our center-to-center measurements for each of those. So let's solve for end-to-end measurements on N. This time they got it right. As we look at how to handle the Y, we'll come to that. But remember that our center-to-center was 26. We took that 44 overall and subtracted 18. So we take 26. Let's see, on the sanitary T side of this, we're going to subtract off a part of that T. We're going to call it D from data table 10. And then we're going to take into account the 1/2-inch thread coming into it. And then from data table 8, this is where they actually did the Y correctly. We have A subtract C. So if we take the A measurement minus the C measurement, it's going to give us 1 3/16. And then taking back off the 1/2 inch for the pipe, let's just run this out. End to end equals 26 minus, in brackets, the 2.5 for this ante, plus 1 13/16 for the Y, minus 2 times 1/2 where the pipe comes into those fittings. That's going to leave us with 22 11/16. Moving on to pipe O, this section is our diagonal. And as we calculated that up, we took 18 times 1.414. We came up with 25 7/16. Now, what are we going to subtract? Well, it's coming out of that Y. So we've got to subtract off D. That's the section coming from the center line to the face of the branch of the Y. We find that on data table 8 is 3 7/16. And then we're going to take off from that 1/2 inch for the thread end on the pipe. Going back to data table 5, we're looking at a 45-degree fitting, and we get 1.5 inches is the face to center measurement, and subtract off 1/2 inch for the thread end of the pipe. End to end equals 25 7/16 minus, in our brackets, here's our takeoff, 3 7/16 plus 1.5 minus 2 times the pipe threading in, that's 1/2 inch, and altogether we're going to end up with 21 inches. Let's solve for pipe P. Center to center was 12, that's given to us. We go to our data table and we had already found the 45 is 1.5 inch. We subtract off the 1/2 as it threads in. Data table 10, this time we're going to use the section C for our sanitary T. That's 2 7/16 and the 1/2 inch that the pipe threads in. In the end, we get end-to-end measurement equals 12 minus, in brackets here, 1.5 plus 2 7/16 minus the 2 times 1/2 where the pipe threads into the fittings, and we end up with a total of 9 1/16. Alright guys, we have one more sample problem. We're going to get to sample problem 3, but I just want to point something out. They're not giving us all the steps like they used to, and again, this book is progressive. As we prove ourselves and as we practice these step by step, they're assuming that we can figure all that out. You know, we could do that all on paper, but they're just going to crunch it and say, here's the answer. Hopefully you're okay with that, but let me point out, as we're doing these, it's really good, it's really important to be able to do fractional calculations like we've seen, and be able to add and subtract fractional measurements. But as long as you've proven yourself, you know how to do that, especially when cranking out all of these exercises, I'm going to say get the app. Get the app that can add and subtract measurements to the fractions, right? So that you can just put these numbers in, do your subtractions. Now, when you're using the calculator, remember, punch it in twice just to make sure you didn't, accidentally enter it wrong and get the incorrect answer, but check yourself. But it's going to speed you up a bit, and I'm totally fine with that. Like, use a calculator, right? You can get an app on your phone. You can buy a construction calculator that has the buttons, and you can enter in measurements, feet, inches, fractions of an inch, and you can just crank them out. That's how I'm going to recommend we do these as you're continuing through this book, because that's fine. You can use that out in the field, right? Why not? If you're going to be subtracting all kinds of fractional measurements, use a calculator. That's why they made it. Here we have sample problem number 3. This diagram's a little different. There's a lot going on, but notice here they're only asking for one solution. We're looking for Q. Now Q is that pipe between the Y's on the bottom. Let's discuss how we can find that. We're going to use information on this diagram outside of that to find it, and we're going to have to pull from here and there. Let's start at the top though. The top, we have this measurement of 36 from center of santee to center of santee. That's where those Y fittings end up. In reality, the centers of those Y's are not the same, and we can tell that because if you look on the left side, outside of that santee at the bottom, it's 8 inches. Now that's 8 inches from the center line of those Y's up to that 45 in the middle. And then on the other side, the right side, we have 10 inches. So when these pipes come out of those Y's, they're different. But let's use what we know about triangles. These are right triangles with 45-degree angles. So if one side is 10, say that one on the right, then the other side of that triangle across the bottom is also 10. So we take that 36, we say, all right, 36 subtract 10, that's going to get me to the center point of the Y on the right side. Now what about the other side? 36 minus 10 is 26, so that's to the center of the 45, but now I need to add something coming from that point over to the center of the Y. Using what I know about triangles, if that vertical is 8, then coming across from the center of the Y to where that 45 and Santee center, well, that's also 8. So I can say, well, what I have left after subtracting 10 from that 36 is 26, but now I can add back to that as it's coming past that center line 8 inches, and that's going to give me a total of 34. So there we have center to center equals 34 inches. Then we just have to figure out our end to end. Let's have a look at their solution for pipe Q, our center to center. They're going to say center to center is overall minus the outside run plus the inside run. Outside run was the 10, inside run is that 8. So we get 36 minus 10 to be 26 plus 8, that equals 34. That's how we come to our center to center. Now as we take off for our fittings, we're going to subtract for the Y on each side. It's going to be the same size Y. We're going to subtract for one portion on the one on the left. If we go to data table 8, that's C. That C section is from the face to the center of the branch connection there. And that's 3 and 7/16. And then we'll add back for our pipe threading into the fitting. And then on the other side, we have that shorter section from that center line branch connection point, where we're going to take A and subtract C, and that's going to give us 1 and 13/16, and then the pipe threads into it 1/2 inch. So here we are. End to end for Q equals 34 minus, in brackets, we have the 3 and 7/16 plus 1 and 13/16, and then we're going to subtract off 2 times the 1/2 inch where pipe threads in. That's going to give us 29 and 3/4 is our total end-to-end length for Q. Hey, we made it to the end of our sample problems. Obviously this has been a longer video presentation. Some of our other math units, we can get through the sample problem pretty quick, but with this one I've tried to present and be a little more thorough, and it's now time for you to work on your exercises. There are a total of 16 different problems you'll get to do here. Now recognize that this is part of the time that you spend as an apprentice. Please make sure to go through each of the exercises, figure up your center to center, then figure up your end to end, adjusting for and taking off for your fitting allowances given the type of pipe and size of pipe that they have on each of those tables. Keep up the good work, be persistent,